Dear organizer, dear delegates, my name is Michel Pieraccini, for those with who I didn't have already the chance to cross our paths yet. And I'm working as EDF International Cooperation Director, so in this case I really thank the European Commission to have invited us to present our activities in the predisposal field. And on behalf of Sylvain Granger, the EDF Director in charge of all waste management group and decommissioning activities of EDF, I will present some insights for you resulting from EDF experience about predisposal activities and particularly about radioactive waste management. I will therefore describe the big principles of our strategy in this field and submit some suggestions and thoughts for further improvements, including R&D, of course, in connection with the European Joint Programme of Waste Disposal to enlarge joint implementation on joint programming. Okay, good, it works. So therefore, my presentation will be articulated as follows. I will first remind some global principles about the context to be faced. Then I will describe some of the lessons learned by EDF throughout its activities in the last 20 years in the waste management and decommissioning field, in order to be able to propose you some suggestions regarding today's topic and to conclude by some perspectives. It works. At first, it could be useful to remind the global context of the overall nuclear industry situation in the European Commission. On the left-hand side, the pie chart shows that out of the 222 reactors installed in the European Union, 128, the one colored in blue, are now operated. And this number is to be compared to the 451 reactors which are operated right now worldwide. In addition to this value, we have to figure that one-third, nearly 94 reactors, the ones that are colored in brown, are shut down or waiting for dismantling or already under dismantling, but this is to be relied to the 171 reactors in the same situation worldwide. As you can see on this picture, only a very few of them are fully dismantled, and for only a few, a long-term safe enclosure has been decided. You can see on the map the distribution also that enlightens the fact that the three main actors are UK, France and Germany, but there are quite some differences between them, depending on their technologies, like old generation of gas-cooled reactors, mainly in France and UK, and also very big differences between national policies regarding the nuclear activities. The map also illustrates the share of other countries. This very brief overview highlights that the global nuclear industry has entered into a new era of decommissioning activity. More nuclear facilities are coming to the end of their operating lifetime, while others are being prematurely closed due to market forces and or national policies. With an ever-increasing number of sites beginning this process, decommissioning associated activities with managing these materials and waste present a global challenge. As a matter of fact, to address predisposal strategy, which is the aim of this session, it is necessary to examine waste management at first, and consequently to examine decommissioning as it has become and will remain the growing source of production of materials and waste to be managed for the next decades, particularly in Europe, which waits for more than 40% of this worldwide field in the next 20 years, at least. So I suggest to remind some principles about decommissioning. It is often considered as the death of a nuclear facility, whereas in fact it's just one of the three normal steps and usual steps of a nuclear installation life cycle, which are design and build, as illustrated here, then decades of operation, and of course, then dismantling and decommissioning. Decommissioning, generally, in order to enable to reuse a site for countries that are reasonably sized, like we have in Europe. We are not talking here about China, about the States, and so on. But in a reasonably sized country, we have to figure out decommissioning in order to be able to reuse a site. So, as shown here in this picture, materials and waste are generated all along the three steps of the life cycle. It can be highlighted that there is now a global international agreement within the nuclear industry to link the word waste to an ultimate status prior to disposal. To reach this aim, all materials being generated by nuclear activities are to be accurately characterized and sorted in order to significantly reduce the amount of real radioactive waste to be disposed of. This thoughtfulness of nuclear waste producers has been increased over the last decade, since repositories are considered as rare resources to be preserved. And I don't think my colleagues from UNDRA will complain about this. This is really compulsory in order to limit as much as possible environmental impacts. Users of nuclear repositories assume so far the responsibility, enhancing their know-how in waste management, as well as increasing their credibility by mastering techniques and costs, avoiding, when possible, to uselessly spoil resources by disposing materials which could have been reused or recycled. Such continuous improvements is well taken into account during the three usual steps: design, construction, operation, and decommissioning, that constitutes the normal life cycle of a nuclear facility to mitigate as much as possible the volumes of radioactive materials devoted to disposal. Nevertheless, to achieve this aim, in order to demonstrate the real efficiency and relevance in managing waste and materials from cradle to grave, as we used to say, and we have heard this sentence several times during this meeting, it is to be developed specific skills, specific labs for characterization and sortings, specific treatment facilities, including those for recycling, as well as for disposal. This mastery of waste management has become the cornerstone of successful dismantling and a mastered decommissioning. If we consider the great diversity of type, nature, and activity of waste generated by decommissioning, as well as all the involved quantities, the back-end activities logically appear as the main source of waste to be disposed of, and they have a huge impact on pre-disposal activity. So as a consequence, as it was questioned, ambitioning to include and integrate on pre-disposal relevant R&D programs and innovation in waste management assume that all various facets of decommissioning activities have been formally tackled and addressed to gather sufficient OPEX and feedback to get confident in certain processes, as well as to be able to identify some remaining needs commonly shared on the international scene. And in fact, this is exactly the point. Fostering international cooperation to share experiences, to mutualize tools, techniques, and know-how, to implement and improve appears as the only way to a greater efficiency, a greater sustainability, but also a better stakeholders' confidence, and the most important, the public acceptance. Let's talk a little bit more about this. Usually, the NPP's owners or operators assume their responsibilities in safety and efficiency all along the three steps that we talked about: design, operation, and decommissioning. As is characteristics of being both owner and operator, EDF assumes its responsibility through an architect-integrator model with the same concern of quality and efficiency during the three steps. EDF is applying this strategy on its currently 73 NPPs operated in France, but also in UK. But what is less known is that EDF is also decommissioning 9 old generation plants for the last 20 years, which, coupled with the 40 years of nuclear operations of other NPPs, have given to the company a very strong OPEX and a huge experience in waste management and decommissioning. To structure and reinforce the industrial knowledge and to prepare the future challenges, including pre-disposal activities, EDF created in 2015 a dedicated directorate called DP2D, and we added its holding SiteLife. On this slide, you can see on the right-hand side the illustration of the 9 old reactors being already under decommissioning by EDF DP2D teams. These 9 reactors are of 4 different technologies. You have a fast breeder reactor in Cres-Marbil on the right back side, and you have also PWR in Chaux on the upper part. You have an heavy water reactor on the left in Brennelis, and you have 6 graphite gas-cooled reactors. All of them are spread over the 6 different sites. So DP2D is performing their dismantling, gathering, with its holding cycle life, all the group devoted skills resources means in waste management and decommissioning. And the purpose is to reinforce EDF capacity in this field, identifying remaining needs, including R&D and specs, and to address them pragmatically, adapting also operators training, experimenting and adjusting innovative technologies in order to prepare the future internal challenges. It is to be prepared, it is to prepare the decommissioning of the now operating fleet when will come the time to shut it down, but also to provide services to our partners, glancing at some complementarities, developing partnerships and international cooperation to share experiences. And international cooperation, sharing experiences, this is in fact the point. So let's have a big highlight on this. EDF DP2D strategy really encourages international cooperation, and this is directly visible from its structure, relying on all suitable complementarities and knitting some strong links. This new structure of DP2D Directorate has been conducted in 4 concentric phases, as illustrated there, and reporting directly to EDF board and gathering all skills, resources in waste and project management. It has been completed by all specialized entities and subsidiaries which are essential, crucial to address waste management and decommissioning facets, as well as increasing EDF group autonomy, its technical and financial mastery for not only its own needs, but also its partner and customers' one. The establishment of industrial partnership and international cooperation regarding the identified key technologies or targeting some geographic areas has naturally completed the initial droplet. So such structure enables a continuous improvement of its know-how and its operators' ability, fostering the share of experiences, the partnerships, the complementarities, including innovation, regulatory evolution, being as close as possible to customers in order to listen to their needs and to engineer them tailored, optimized solution. Our facilities and partnerships allow to benchmark and to improve new techniques and, if necessary, to support and adapt dedicated R&D matters, including operators training. On the 2 next slides, you have several illustrations of operational realization to which I've conducted the strategy and organization. So you've got the different examples taken on our sites under decommissioning. You have also here some other examples of PWR, of fast breeder reactors on graphite gas reactors operation. And it is to be kept in mind that all the dismantling of the 4 different technologies that are spread over the 6 different sites in France on 9 different nuclear reactors and associated facilities, all this is performed in parallel. This is an EDF particularism, which is not so common among nuclear operators. And if it has provided EDF with some sound experiences in France, it has moreover provided some lessons hardly learned. Like, for instance, the fact that all nuclear technologies are not equal regarding dismantling, as it is illustrated there. For instance, I don't know if we have all this in mind, but it is to realize that there is a huge difference between graphite reactors and PWR ones in terms of size, volumes of materials being generated, quantities and nature, types of waste to be managed. As illustrated there, there are easily ratios from 5 to 10, and sometimes even more, depending on the matter. So a hurry in this field could be hazardous with huge consequences for the whole nuclear industry credibility. For this purpose, it is to be careful and pragmatic. Thus, regarding the current 58 PWR-operated reactors, the feasibility of their decommissioning is currently assessed, and it is already regularly checked, and now we concentrate on how to optimize and to take advantage of the serial effect in terms of skill, resources, and this is also valid for predisposal activities. Regarding graphite reactors, the situation is a bit different. None of them have been really dismantled till now. Only 2 small ones, Wagga in the UK and Forsambra in the United States, but their sizes are not representative at all to what is now expected. It remains a stake. Decommissioning a graphite reactor remains a stake. It needs innovative tools and sound assessment, as well as operators training. As a consequence, it is to be cautious, examining all cases thanks to a risk mitigation approach, which will allow anticipation, flexibility, as written here, reactivity, but which imposes also to have in mind that significant dismantling timeframes will be expected. Another lesson learned is that this risk mitigation approach can only be really pragmatic and efficient if it is combined with a strong project and program management, and also on a complete and efficient waste management system. Thanks to our colleagues from UNDRA, we have this one, and this one does exist, and it is operational in France. It works. Nevertheless, it can be improved. And it can be improved by implementing clearance levels, for instance, but also by homogenizing regulations, criteria, to enable an honest representative benchmarking of the different existing techniques, but also to assess the real operator's ability based on an equal and common basis of references. Enhancing communication between stakeholders, we have also tackled this topic this morning and even talking about knowledge management, but enhancing communication between stakeholders by involving locals and regulators is also a key to success. But educating people is compulsory, and you are all here for this. So in order to avoid any kind of misunderstanding, like the experienced one regarding the notion of immediate dismantling, for some, it should be useful to refer back this notion of immediate dismantling to its initial statement, meaning as soon as possible after shutdown and not promptly in a hurry at any risk and any cost. A common and harmonized regulatory framework internationally commonly shared is therefore still needed. Of course, among all lessons learned, the notion of suitability assessing cost and ensures the mechanism to provide funds on time appears also as a key. Funds include also to identify R&D needs and to support them. The challenge is to get the results of improvements on time, and it has been highlighted by several international cooperation within the OECD, the NI 2050 work, but also within the European Commission and of course within several programs within the IEA. It appears therefore to better improve the efficiency of existing means, but ensuring the mastery also of their operators by reinforcing the training rather than going to new developments with no guarantee that they will be available on time. We have already evocated the necessity to establish communication between all stakeholders since the earliest phases, but it results from all the lessons learned over the last 20 years that there is still a need for improving. For instance, improving education and public acceptance, improving harmonization of criteria and, of course, the regulations between countries, improving also the tools, efficiency, and prioritized abilities. And these suggestions, these findings, are the foundation of the next EDF suggestion I'm about to present you. So based on the previous lessons learned over the last 20 years, EDF suggestions are of two types. The first one is regulatory considerations in order to foster circular economy. We will come later on this, and also to improve international cooperation. And the second suggestion deal with technical and experimental improvements. So let's go a little bit deeper on this. Regarding regulatory aspects, we have already mentioned the need of harmonizing regulations between countries based on common directives. This will not only foster the necessary circular economy to optimize waste management and to preserve natural resources, but it is also essential to increase public acceptance. It is a key to avoid any kind of confusion in public's mind caused by using different criteria. Like, for instance, the criteria of clearance level 1s between neighborhood countries. It's quite impossible to make somebody understanding that which is allowed in one side of the border is totally forbidden in the next border, in the other side of the border of the neighborhood country. This is really a drawback for the nuclear industry. So this harmonization is also compulsory to enable the share of techniques or the treatment facilities or future multinational repositories, as it was evocated there this morning, or simply to assess the real know-how as well as benchmarking the tool's efficiency and operators' ability on the same basis, and therefore to really develop international cooperation and to ensure its commitment. So, regarding the second field of suggestion, the technical improvement in waste management and decommissioning, including R&D, it should be incentivized, firstly as agreed by international experts, for existing tools, processes and treatment efficiency, as well as for operators training. But this highlights the need of the imminent availability of industrial demonstrators to increase operators' ability and their confidence, but also to test alternative solutions while facing unexpected situations which will undoubtedly occur, as none of the mentioned reactors have been designed to be decommissioned one day. And this is to be kept in mind also. So these future demonstrators will be the ideal cover to safely test innovative techniques like virtual reality, and also to foresee to progressively and safely replace human operators by robots, where nevertheless the human know-how and on-time adjustment, on-time decision is inevitable despite high dose rate exposure. So following this finding, EDF has conducted 2 new projects. The first is a brandly new one, still under discussion, by the way, of a future centralized treatment facility. And the second is a more advanced international industrial decommissioning demonstrator to be soon settled in France and already gathering the interest of several European countries. So, first designed to, as the first one is still a brand new project, we will just focus on the second one. So the first design, it was first designed for graphite reactors dismantling in order to assess and to improve the scenarios, but also to improve remote handling tools and the operators' training. It is a result of EDF risk mitigation approach I've proposed, I've explained to you, and that was shared also with international peers in charge of similar problematics and who testified their interest for such a facility. This demonstrator has the advantage of its modular conception, allowing further evolution. It will be operated from 2022 and be located in Chinon, as illustrated here on the map on the right upside. Chinon constitutes an ideal European central position regarding the location of NPPs in Europe, if you remember the first pie chart on the second slide. The demonstrator will allow the use of existing techniques like virtual reality and remote handle tools, but also to experiment innovative ones and train operators from various horizons on various thematics, including how to optimize predisposal activities. And we will come back on this later on. It will appear as a useful industrial means to implement safely R&D, to test safely and at mastered delays and cost and any improvement thanks to the use of representative mock-ups, enabling to face unexpected situations. It will also enable to assess the volumes of waste, including secondary ones, optimizing the number of packages and predisposal conditions, aim of today's topic. This is to keep, the little picture here is to be kept in mind, because if you make the assessment of all the quantities of waste being generated by decommissioning, you realize that one of the greatest advantages of such a demonstrator is that thanks to its modularity and its representative size 1 mock-ups, it will enable to intensify and to improve the development of the use of exoskeleton in decommissioning and dismantling. So operators from various communities and citizenships could train themselves and share experiences piloting robots in high-dose exposure context and to act safely as if human operators were really operating on site. This will allow to increase safely dwindling risk and enlarging working time from 2 to 3 times, reducing drastically in parallel the collective dose as well as waste volume due to clothing. It will assuredly constitute an asset to improve technical and financial mastery, as well as reducing environmental impacts, showing decommissioning as a back-end activities, but no longer showing battles now as an innovative field of progress. And in order to conclude, So I tried to be in a hurry to recover the time. So I hope I did my job nearly. To conclude, it may only be necessary to remind that all EDF strategy, including R&D considerations on predisposal and improvements, is based on sound experience of 20 years of lessons learned in that field. Nevertheless, there is still some place for improvement, mainly by fostering regulation, harmonization, and criteria. This will ease, as we talked, the circular economy, as well as establishing common references of efficiency, enabling a rigorous assessment, but also facilitating the identification of remaining lacks and the needs, including the R&D aspects. Then, in order to remind that we should all promote and take advantage of international cooperation instead of focusing on the competitive market characteristics of waste management and decommissioning, the common rules and common understanding are necessary to strengthen the public acceptance and, at the end, the nuclear industry credibility itself and its future as an unavoidable component of a mixed energetic policy. For such an objective, an international commitment is compulsory, and undoubtedly, international organizations, and particularly the European Commission, are the best asset to promote the European know-how worldwide. So I think I'm still right on time. Thank you. Sorry to have been obliged to speak very rapidly and to read partly of my program just in order to be sure that I will be in time, because I knew you will be fed up at the end of the day. This is the worst place. So I tried just to say, okay, I let them sleep because the most important will be the panel, and I let them sleep during the presentation just in order for them to be really reactive and efficient during the panel discussion. So thank you very much for your comprehension.
Michel, thank you very much for accepting to come and present this utilities view. We've not worked very much until now together, but I hope that the discussion now will be able to give key messages on how to work together and be effective. Thank you very much.